time before last, when we were talking about Earth's history, first we talked about some theology, philosophy things, and then we talked a little bit about how scientists know or estimate or conclude or theorize, pick your favorite word, how old the Earth is, how old the universe is, how long ago life emerged on Earth. And so today we're going to go into a little bit more detail on that. We talked about the law of superposition already, and we briefly talked about the difference between relative and absolute dating. Yes? Is that how far we got? Does that all ring a bell? Okay, so we're going to run through the stuff we've already seen briefly, and then we're going to talk a little bit more about things like dinosaurs. All right, so let's start with Earth's history and how old is the Earth. Based on the technology available to us today, the Earth is estimated to be 4.5, 4.6 billion years old, roughly. Okay, that is, again, based on the scientific evidence that we have, and we're going to talk about what that scientific evidence is. Okay, here we go. Earth age, evidence. First of all, there's the law of superposition, which we already talked about. If the rock layers are undisturbed, it's a big if, younger layers, younger rocks lie above older rocks, and the oldest rocks are at the bottom. Now, what might disturb layers of rocks? George?
Nuclear explosions.
Yes.
Earthquakes.
Earthquakes. Volcanic activity.
Asteroids.
Asteroids, okay?
Sinkhole.
Sinkhole.
Meteors.
Meteors.
Tsunamis.
Tsunamis.
Weathering.
Weathering.
Any other natural disaster.
Any other natural disaster?
Chuck Norris.
Very good, yes.
Oh, man.
Man, okay, so we can pick up and move. Construction, building, mining, all kinds of things disturb layers of rock. As time goes on, fewer and fewer undisturbed layers of rock exist because, for example, if you've ever driven around on 360, you see all of the road cuts where they have cut down into a hill to make a road not have to go over the hill, but it can go straight through the hill. All over the country, that has been done to make roads, and it's actually really good for geologists. It sounds bad, but it's really good because now those rock layers have been exposed, so a geologist can go and look at the rock layers without digging themselves. The construction companies did that for them. All right, here is a picture that obviously you can't read it from there, but you don't need to. But this is a diagram of different layers of rock, and it's actually layers of rock that it's sort of they're the layers of rock in the Grand Canyon. But these, yeah.
Why is it curved like that?
Because it's
like
this is the edge of the Grand
they
Canyon that's
just cut out a
exposed, and then they just cut this piece out so that they could write stuff.
Yeah, it just looks really weird.
Yeah, it does. Okay, these are the layers in the Grand Canyon, but these same layers or rocks with these same ages have been found in other places in the country. It's just that this is the place where they've been exposed to the surface so that we can see them. And, these rocks are very new, relatively speaking, Paleocene. These are Cretaceous rocks, Jurassic, Triassic, Permian, and so on. So the absolute ages of these rocks that's described on here, they found a different way. But relatively speaking, just by the order, these are undisturbed. They're cut here, but they haven't been uplifted. They haven't been shifted any. You can tell because they're relatively flat, and therefore you can say that these are older than these. Does that make sense? Okay. Now, if these were igneous rocks, some of them are, some of them aren't. But if there's an igneous intrusion, like right here, okay, this igneous intrusion might be younger than the sedimentary layer that's there. So this would be remember we said undisturbed, this would be a disturbance of this layer, that this magma came and melted in here and created an intrusion. You also see that these layers are tilted. Again, they're tilted by some kind of seismic activity. and therefore there's some disturbance here. You know that these are all, at least these layers right here are probably younger or older than these layers, but you don't necessarily know the relative age of this igneous intrusion. Does that all make a little bit of sense? Good.